Let's look behind the scenes how Ax.CEPH works. Let's create reference points, the first, the second, and the third. Then we make a plane by connecting 2 points. Using the third point as a reference, we create another plane perpendicular to the first one. If we now move one of the points that define the first plane, we can see that the whole geometry is changing. Let's put on another point at the crossing of the 2 planes. This new point also moves with the geometry. Let's create another plane at the location of our choice, and then another plane that goes through an existing point and is parallel to the first plane. When moving the geometry, the whole movement is predictable in a way that we have defined during the construction. Let's integrate some measurements next. First, the distance between points. When moving one of the points, the distance is calculated simultaneously. The same is true for the angles. We can place the angle measurement between 2 planes or between 3 points. We can change the measurement to be for the supplemental angle by issuing a simple command if needed. The measurements are being refreshed while moving the geometry. The same holds for all the other points and planes that can be seen in the tree structure on the left-hand side, even if they are not currently visible on the X-ray image. The visibility of individual elements can in fact change by using hide and show commands. Let's choose a couple of planes that we've just created. When hiding them, only the remaining points and measurements are still visible on the X-ray image. The whole mechanism is still being refreshed because the whole of it remains in the background, even if only a part of it is visible. Let's select all elements in the tree structure and make them visible by using the show command. You can see that a complex geometry exists in the background of our analysis, and if we move point A, for example, many elements move accordingly. When we place point A to its correct position, the measurements become accurate. Since the elements exist on different layers, we are able to selectively display only those that are part of the current analysis. That way the image is less cluttered while only the points and planes that are needed for the diagnostics are visible.